Going to start talking about our conic sections today. Now, as I had indicated to you earlier, this unit's test is going to be a take-home, so it's going to be a free 100. It's going to be just a standard test. So I'm not a free 100, but it should be a pretty easy 100. If I said free 100, I hereby retract that one. But it's going to be an easy 100. Most people on this test get that or something very close to it, if they tried on it at least. So what is an ellipse? Well, this is an ellipse. An ellipse is simply the set of all points P in a plane, the sum of whose distances from two fixed points, F1 and F2, is constant. These fixed points are called the foci, which is the plural of focus. The midpoint of the segment connecting the foci is the center of the ellipse. Now, an ellipse can be elongated in any direction. The line through the foci will intersect the ellipse at 2 points called the vertices. Now, if you wanted to get kind of technical, these could be vertices too if you really wanted to get technical, but we're going to call them vertices at the ends of the major axis. And the midpoint of the major axis is the center of the ellipse. The line segment whose endpoints are on the ellipse and it is also perpendicular to the major axis at the center, that's going to be called the minor axis of the ellipse. So we have two forms of the equation of an ellipse. And basically, major and minor axes of 2A and 2B. So basically, in this case, this is where the major axis is horizontal. And this is the vertical major axis. Now, we're going to talk about those C values in just a little tiff here. Now, A squared is going to be greater than B squared no matter what. So basically, if you look and see the larger of the two is under the X, then it's going to be a horizontal major axis. And if the value under the y-axis, under the y squared is larger, then it's going to be a vertical major axis. Now, there is a conics app in your calculator. And yeah, you can choose your a squared value. And right now, we're just focusing on those being centered at the origin. So basically, yeah, we'll figure out how to graph these here. Now, the vertices, as we said, are going to be on the major axis, A units from the center. The foci are on the major axis, which is C units from the center. And what will happen is, for both equations, B squared will equal A squared minus C squared. Now, here's the thing. Yeah, this is one of the other reasons why I make this a take-home test. Because the equations for the foci do change with all of our conic sections. So, in other words, it's not that consistent. It's not very consistent, so to speak. So, the foci will go on the major axis, C units from the center. So the other point of an ellipse is the other side has to equal 1. So we're going to graph and locate the foci of the ellipse given by this here equation. So the first thing we need to do is divide everything by what? to get 1 on the other side. 144. And not coincidentally, what is 16 times 9? 144. That's pretty gross. You get that? 144 gross? That's how many are in a gross. Y'all didn't know that? Oh, it's okay. You know what? I didn't learn that in school either. So anyway, this is going to be x squared over 9 plus y squared over 16 equaling 1. So basically, the major axis, is the major axis going to be on the horizontal or the vertical? It's going to be on the vertical. So yeah, you're going to have a vertical major axis here. So basically, your A value is going to be 4, and your B value is going to be 3. So we're still going to be centered right smack dab at the origin. So since the vertical axis is going to be our major axis, you know, you'll go 4 up and 4 down from here. And the horizontal is your minor axis. And they're going to be located 3 units from the center. And it's going to wind up looking precisely like this. Now, one thing you can do is you can even graph this on your calculator. I'll show you how to do that. Yes, A and B are always going to be perfect squares in this class. Yeah, I mean, if A and B were not perfect square, yeah, it would get ugly if they weren't. I mean, technically, yeah, they don't really have to be, but I'm going to always make it that way because like if this B value were, say, square root of 8 and the A value were square root of 17, you know, it wouldn't result, it would still result in a ellipse.
It would still result in a circle, it just wouldn't land on any.
It wouldn't land on integers. Yeah, these are going to always be integers, is what I'm trying to say. But if the A and the B values were the same, then we're dealing with a circle. FYI. Now, so if we go here, actually we want to go to this one here where the vertical axis is your major. And let's see here, your A is 4, your B is 3, and we're centered at the origin. And it's going to look just like this. So, now find the coordinates of the foci. Now, if you remember, you know, c squared will equal a squared minus b squared. So the c value may or may not be an integer. That's okay. That's quite okay for us here. So basically, yeah, c squared will equal 4 squared minus 3 squared, which is 16 minus 9, which is 7. So c will equal plus or minus the square root of 7. Now the square root of 7 is 2 and change, which is approximately plus or minus 2.65. Now, since the major axis is on the vertical, basically your coordinates for the foci are going to be at 0 plus or minus c, which is going to be right about here. Now, believe it or not, the foci will have some other attributes to it that we can talk about at another time as well. So basically, yeah, it'll be at 0 plus or minus the square root of 7. Now, so actually in this next example, yeah, the b value is actually going to be not an integer, but you might be given the equation, foci and the major axis vertices. So you'll have to figure out the b value based on that. Let me see what you can do with that. And again, I'm sorry, vertices are at plus or minus 3 and 0, 3, 0, negative 3, 0. We know the equation is going to start off with x squared over what? It's going to be x squared over 9. Very good. And it'll be plus y squared over something, and that'll equal 1. Now, here's the thing. Our foci are going to be at positive and negative 2, 0. Now, of course, if you remember, I shouldn't say that because, yeah, you can reference this. C squared will equal a squared minus b squared. And you can manipulate this equation or whatever, but basically your c value is 2, your a value is 3. You have 2 squared equal to 3 squared minus b squared. 4 will equal 9 minus b squared. Negative 5 is negative b squared, so b squared is going to be 5. So it's going to be y squared over 5. Now, as you'd asked, wait, the a and b value is going to be integers? Only in a case like this will they not be, where I give you the focus, and frankly, I'm just not even, yeah, because we're going to be moving it away from the center, but the a and b values for any kind of question you get on particularly the test, which again is a take-home, it will be, they'll be integers. How do I know? Okay, the foci are given to you. Foci is this, it's C. So that's how you know. All right. Yep. And if you notice, yeah, the foci and the major axis, they're both x. So that's why we know it's going to end up being this. Now, so it's going to look just like this, a little over 2. And I wish my drawing skills were more up to par than this, but yeah, that looks kind of bad, but exactly. Yeah. Thing is, I don't know what it is, but whether the horizontal or the vertical axis is at, whether the horizontal or vertical axis is your major or your minor, like in this case, the horizontal axis is going to be your major. In the next case, bless you, I think it'll be kind of the same thing, but basically the center for this is going to be located where? To negative 3. So you'll figure out the major axis, the minor axis, and the location of the foci. All right, so our center is going to be located at 2, negative 3. This is obviously a horizontal major axis. And we're going to go, so since, what's our A value going to be? And how about the B value? 2. So basically we're going to go 4 units horizontally, and we're going to go 2 units vertically. And it's going to look something like this. So the vertices are simply going to be located at -2, -3, and 6, -3. Basically 4 units away from the center horizontally. Again, we call them the vertices because they come from the major axis. So our foci, whatever the x values for the foci are, now that's going to be a little bit tricky here, but they are going to be along this axis here. So the foci will be at somewhere, it's actually going to be 2 different values here, but -3 is still going to be the y value. So we need to figure out the c value, but it's not going to be outright plus or minus c here, because we've moved it, and you'll see how this all works. So let's figure out that c value, which is 4 squared minus 2 squared, which is 12. So c will be plus or minus the square root of 12, which is also plus or minus 2 root 3. Now, 2 root 3 is going to take on a certain value. Let's see here. 2 times the square root of 3. As a decimal, it's roughly 3.46. So what we do basically is from the center, we literally go 3.46 units away from here. If we go 3.46, which is going to put us right here, it's going to be basically, there's going to be 2 coordinates for the foci. -3 is always going to be our y value. So the x value is 2. It'll be plus 2 root 3. And then 2 minus 2 root 3, which puts us right around here. Now, if you figure out the approximations here, 2 plus 2 root 3, it's going to be at 5.46. 2 minus 2 root 3, nerds, -1.46. So yeah, that's where they're going to be located. All right, now, for this next one, you have to divide out both sides by something. All right, so what we do here is divide everything out by 225, and we get basically x plus 2 quantity squared divided by what? 25 plus y minus 3 squared, and that's divided by 9 equals 1. So the center is going to still be located at -2, 3. -2, 3. And we're still going to have a horizontal major axis. Oh, my center disappeared. There we go. So, your A value is 5 and your B value is 3. So we're going to go 5 units away horizontally and 3 units up and down vertically. Oh, see, that's a little better. Close enough for government work. All right, so yeah, the vertices for this bad boy are at -7, 3, and 3, 3. Here's the thing, the distance between these two vertices is 10 units. Half the distance is 5. Boom. So you'll need to figure out the C value in order to figure out your foci. All right, so when we go to figure out the C value, it's a squared minus b squared, which is literally 25 minus 9, which C is going to be actually a pretty good one here. 4, C squared is 16, C is going to be plus or minus 4. In other words, we really lucked the heck out on this. So basically, the foci are going to be located 4 units away. And you could think of it like this. -2 plus or minus 4, and at 3. Well, -2 plus 4 is 2, and -2 minus 4 is -6. All right, now, that's how we find the foci. Yeah, we kind of lucked out in that sense. Now, in the next one, we're going to be having to complete the square. So, I love completing the square. Now, first thing you should do is move that 99 over. And let's kind of put the x's and the y's together. So what you'll do here is, in order for yourselves to complete the square here, you'll need to factor out the appropriate values. In the case of the x, you'll factor out a 36. That becomes x squared. 144 divided by 36 is... So 4x plus a blank plus 9, and it'll be y squared minus 6y plus blank. And it will equal, the other side will still equal 99, but you're going to be adding not just what you put here, but 36 times that on the x end, and 9 times whatever it is on the y end. What's going to complete the square for the x? 4. And how about for the y? 9er. So we move. So basically, we get 36 times x plus 2 quantity squared plus 9 times y minus 3 quantity squared equal to something on the other side. But it is actually going to be whatever 36 times 9 is. Because here's the thing, 99 plus 36 times 4 plus 9 times 9, which is 81, 324. So if we divide out by 324 on everything, 36 times 9 is 324. So basically, we're left with x plus 2 quantity squared over 9 plus y minus 3 quantity squared over 36 equaling 1. So now the vertical axis is your major axis here. But the center is still going to be at -2, 3. Right here. And vertically, we will go 6 units above and 6 units below. Horizontally, we'll go 3 to the left and 3 to the right. 1, 2, 3. 1, 2, 3. And it'll look something like this. Nope. Close enough. Now, our foci coordinates are going to be located where x is going to be -2. But we need to figure out the c value, which is still a squared minus b squared, which is 36 minus 9, which is 27. C will equal plus or minus the square root of 27, which is plus or minus 3 root 3. And here's the thing, 3 root 3 is 5.2. So basically, you're going to go 5.2 units above and below. So the foci are going to be at -2, and let's see here. This is going to be 3 plus 3 root 3, and -2, 3 minus 3 root 3. So that's what you're going to get on that. Now, before we move on to the next example or whatever it is, I do want to show you how it can, show you that everything I'm talking about is true here. So it's not like I'm just feeding you a bunch of nonsense here. So what I did was I went to the TI Inspire and you can graph this as a conic or you can graph it as a relation. I just graphed it as a standard relation. If I analyze the graph conics, the foci, the coordinates of my foci are -2, 3 root 3 plus 3, and -2, 3 minus 3 root 3. So, yeah, that's what we're going to get here. Yeah, and believe it or not, the Casio calculator actually does conics as well. If we do the vertices, and it can even do the center. Yeah, it kind of gets a little crowded though, but it's what it is. All right, how about you try this next one? All right, so in order for us to start this, we'll factor out a 25 here, and this is x squared minus 8x plus blank. We'll factor a 4 out. That's going to be y squared plus 4y plus blank. And this will equal -316 plus 25 times something plus 4 times something. So to complete the square for the x, it's going to be adding 16. And for the y, it's going to be a 4. So you have literally 25 times x minus 4 quantity squared plus 4 times y plus 2 quantity squared equaling, so yeah, -316 plus 400 plus 16, and that's going to be 100. We divide out by the 100s. And we get x minus 4 quantity squared over 4 plus y plus 2 quantity squared over 25 equaling 1. So is our major axis going to be horizontal or vertical? Vertical. We're going to be centered at 4, -2. B is going to be 2, A is going to be 5. So we're going to go 5 units above and below. Should put us right here and right here. And 2 units to the left and to the right. All right, now we'll figure out the C value, which is A squared minus B squared, which is 25 minus 4, which is 21. C is going to be plus or minus the square root of 21. That's not simplified. You can't simplify that. And the square root of 21 is 4 and change. So basically the foci are going to be located at, well, where x is going to be 4, and let's see here, -2 plus or minus the square root of 21. You'll add square root of 21, which will put you probably somewhere about here, and subtract the square root of 21, which will put you right here. So you can give it to me as 2 separate coordinates. All right, so that's going to do us. So who knows what will happen here. So a hyperbola is simply going to be the set of points in a plane. The difference of whose distances from 2 fixed points called foci is constant. So in other words, a hyperbola is going to be somewhat similar to a ellipse in ways. There's going to be vertex points. You're going to have a center. Right now we're going to focus on centering it at the origin. So the line that will join the vertices, that'll be your transverse axis. The focus or foci will be inside of the hyperbola. So you're going to have basically 2 standard equations of a hyperbola. One being where the x squared is positive, and you'll notice that the transverse axis is your horizontal axis that you should see right there. Now, if it's where the y squared is positive, it's basically going to be a vertical transverse axis. Now, basically we do have a new rule for calculating the foci, or the C value. And it's not just like with ellipses. I don't even know why I keep forgetting to do this. But the way we calculate it is B squared will equal C squared minus A squared, or literally A squared will equal B squared plus A squared will equal C squared. Now, the other thing we'll be able to do is to kind of figure out the equation, the asymptotes of a hyperbola here. And it's actually going to be very easy to do. So what I want you to do here is, if you graph this hyperbola here, x squared over 49 minus y squared over 16. So it's literally going to be centered right here at the origin. So you'll have A equal to 7 and B equal to 4. So the axis for the transverse axis is going to be your horizontal. It's going to be the horizontal axis here. So what you want to do is figure out the coordinates of the vertices here, which will be at -7 and +7. Now, here's the other thing. So the purpose of this b being a 4 here is it's going to be 4 units above and below the center here. Now, you're probably wondering, all right, what does this all have to really do with anything here? Well, one thing you can do is think of a box, kind of draw a box here, and we'll actually be able to figure out the equations of the asymptotes in which these bad boys are going to lie on. And if you actually kind of connect the dots here, the purpose of this is very simple. So let's see, 4/7. Yeah, it'll look something like this kind of here. Now what I'm going to do is I'm going to kind of make this a little dashed here. And we do the same thing on the other side. And try to extend it in the same format here. Because here's what's going to happen again. Finally, yeah, you're wondering, why the heck am I doing all this? Well, here's the thing. Basically, making the box is nothing new here, but basically you're going to kind of just draw the curve, and it's going to kind of just straddle this in a way. So in other words, the curves of this hyperbola actually should never really go outside of these vertices here. So what I want you to do real quick is to figure out the c value, and c squared is going to equal a squared plus b squared. One of the many reasons I make this a take-home test is because finding the coordinates of the foci is going to be a little bit more tricky than normal. Here for this, that's going to be real simple. C squared will equal literally 7 squared plus 4 squared, which is 65. So C will be plus or minus the square root of 65, which is 8 and change. So yeah, the points of the focus are going to lie just inside of this. And that's what you're going to get here. Now, of course, you can use the conics graphing app when you want to graph a hyperbola, and in this case, the x value is positive. A is going to be 7 and B is going to be 4. We're still centered at the origin, and it'll look something like this. And what you'll see here is if I wish I could graph like these together in a way, but what I'm going to do is I'm going to go ahead and use my use my TI Inspire. I know it seems kind of silly, but it does have its perks, which I do need to, which I would like to kind of show you a bit here. So yeah, this is what it's going to look like. And here's the thing. If I change the window, like make it maybe negative, not -3, but -30. Okay, it's a +30. And yeah, -30, +30 here. Now, what I want to do here is we have two asymptotes. And the asymptotes are going to be very simple. +4/7 -4/7. So y will literally be plus or minus 4/7 x. Now, it's not going to be as simple when we have the ellipse that is not centered at the origin here. But yeah, if we have the equation of the asymptotes, yeah, and you'll be expected to identify that relatively easily here. Now, if I go to, kind of goes to show here, no, I don't want to do it that way. I want to enter just a ordinary function, bless you, 4/7 x. And when you do that, yeah, see, the not so nice thing about your calculator is you can't graph a linear with a conic. But basically, yeah, you'll see that this curve will never go beyond the asymptote. That's what I'm hopefully impressing upon you today with this. Oh, negative 4/7, yes. I'm sorry, I should have done that from the get-go. Oh, come on. Yeah, negative 4. Yeah, negative 4/7 x right here. Yeah, we see all that good stuff here. Now, of course, Desmos might be better too. Now, the cool thing is this thing will actually figure out equations for the asymptotes and whatnot. Like if I go to analyze a conic, not that one, asymptotes, and I choose this one. Yeah, 4/7 x. Pretty cool. All right. So what I want you to do here is I want you to find the standard form of a hyperbola with the foci at the given points. And everything will be are going to be located at 0, -5 and at 0, 5. So basically, it's going to lead off with a positive y value. So, and this will equal 1 over here. So since oh no, those are the foci, I'm sorry. But still, the vertices are going to be at 0, -3 and at 0, 3. So, needless to say, yeah, the y value is still going to be positive here. What's going to go under the y? A squared, which a is going to be what? 3. So it's going to be y squared over 9 minus x squared over, well, here's the thing. A squared plus b squared equals c squared. Here's your c value. So you literally have 3 squared plus b squared equaling 5 squared. B squared is going to equal 16. B is going to be 4. So you're going to put a 4 or a 16 underneath this. So even though it's got a larger magnitude, the fact that this is positive is going to open your hyperbola up this way. So you have positive and negative 4 here. And what you can do is kind of draw your box, and we'll figure out the asymptotes from this as well. But if you notice here, it's going to be up 3 and over 4. You know, you go up 3 and over 4. Now, if you look at the previous one here, we went up 4 and over 7. Now, A was 7 here. This was B, literally B over A. This is going to be A over B. And one of the things is whenever it's leading off with a y squared that's positive, it's going to be A over B, not B over A. So yeah, literally go up 3 and over 4. If the vertices were like something 0, positive and negative something, comma 0. So that's what you would get. And it's a terrible looking drawing here. But what happens now is basically It's going to look kind of like a little boat here. I mean, if you color outside of the line, I'm not going to slap your wrist. Yeah, see, that's a terrible drawing. Yeah, positive, negative, 3/4 x for the asymptotes. So yeah, we're leading off with a positive y value simply because, um, the coordinates of the vertices indicate that as such. So yeah, basically the curve is going to approach the asymptotes here. That's basically really nothing new here. All right, so basically I want you to graph this hyperbola and identify everything that you see here. Transverse axis is going to be on the horizontal or on the vertical? The horizontal one, yes. So A is going to be 5 and B is going to be 3. So yeah, you're going to go 5 units away horizontally, 3 units away vertically. And you can kind of draw a little box here to form your curve. And we see that we're going to have asymptotes. You go up 3/5 or down 3/5. So literally it's going to be y equal to plus or minus 3/5 x. So, and our curve is going to look something like this. Oh, it didn't touch them, but it's supposed to actually touch those. That's the only drawback to something like, oh, beautiful. And I colored over the line. Oh, send me to my room. All right, we got to figure out the foci. Now, if you remember, c squared is a squared plus b squared. Since it's a horizontal transverse axis, the coordinates of the foci are going to lie on the horizontal axis as well. So that's literally going to be 25 plus 9, which is 34. C is going to be the square root of 34, which is just under 6. So basically, you have plus or minus the square root of 34 and 0 for the foci, which is right around here, right around there. All right, do the next one. All right, so this is going to be a vertical transverse axis. And A is going to be 6 and B is going to be 4 here. So it's going to look something like this here. And then B will be 4 here. And the purpose of doing this is to kind of enable us to draw our little box here. But you go up 6/4 or 3/2. So let's figure out the coordinates of the foci. Well, first let's draw our asymptotes. Kiss my asymptote. Let's see here. Beautiful. done that any better. All right, and we go to draw it, and it's going to look like this. So let's figure out the C value. That's obviously a squared plus b squared, which is 36 plus 16, which is 52. So C is going to be the square root of 52, which is 7 and change. Now, at this point, I mean, yeah, you could simplify the square root of 52, which is going to be 2 root 13. Now, if I'm not going to be so picky, though, because here's why. I mean, frankly, it's going to put us right here. And that's what we get. All right. So, any questions on this one? All right, so you can complete the square on something like this, but what I'm going to do is I'm going to kind of just cut to the chase here. I'm going to make this a little bit simple for you right off the bat. Instead of starting off with something like this, I'm just going to give you the simplified version. It'll be x minus 4 quantity squared over 25 minus y plus 2 quantity squared over 9 equals 1. So it's going to be centered someplace other than the origin. The coordinates of the center are going to be where? 4, negative 2. Now, the transverse axis is going to be horizontal or vertical. Horizontal. So 4, negative 2 is where we're going to be centered here. Now, the A value is 5 and the B value is 3. Now, we're going off not quite off the chain here, so to speak. Yeah. But our vertices are going to be literally 5 units away. So the two vertices are going to be located at 9, negative 2 and negative 1, negative 2. Now, from there, we can go up and down by 3 units and close the box. Now, when we're finding the equation, that's going to be a little bit more tricky, so to speak. But if you notice here, this is, up 3 and over 5 still. So what will happen is we'll have the hyperbola looking something like this here. Now, the foci is going to lie inside of this, but it's going to be transformed. So the foci are going to be basically wherever y is negative 2. So you still have to figure out the c squared, which is 25 plus 9, which is 34. C is going to be simply the square root of 34, which is, 5.8 and change. But if you notice, if this is 5 units here, 5.8 puts us right about here. And then 5.8 puts us right about here. But the coordinates are literally going to be, it's going to be 4 plus root 34, negative 2, and 4 minus root 34, negative 2. Now, for the asymptotes, the asymptotes are being transformed in a way. Now, you're not going to have to give me the fully finished one here, but the slope of these is going to be obviously plus or minus 3/5. However, this is where it gets a little sticky. Now, if you remember point slope, y minus, y sub 1 equals m times x minus x sub 1. What happens here is you have y minus negative 2 equaling plus or minus 3/5 times x minus 4. Now, am I going to make you simplify both versions of this? No. Y plus 2 will equal plus or minus 3/5 times x minus 4, and y will be just simply plus or minus 3/5 times x minus 4 minus 2. Because here's what happens. 3/5 x, so let's see here. 3/5 times negative 4, that's negative 12/5, 22/5, which is roughly here. And negative 3/5 times negative 4, that's 12/5 minus 2, which is, puts us right about here. But that's going to be the equations here. I mean, you could simplify it if you really want to, but I'm not going to make you. All right, I'm going to give you a equation where you'll have to complete the square. So if you'll notice, the x squared is negative. The y squared part is going to be positive, so it's going to have a vertical transverse axis here. And let's see what we got here. So we've got, let's take the 25 out of the y squared. So that's y squared minus 6y plus blank. And we're going to take out a negative 16 from x squared, so that will become plus 2x plus blank equal to 191 plus some things. Plus 25 times that. And since this is subtracting, it'll be minus 16 times whatever went in here. So what's going to complete the square for the y? 9's going to complete the square for the y. And how about for the x? Half of 2 is, you got to take half of the 2 and then square it, just going to be a 1. So you literally have 25 times y minus 3 quantity squared minus 16 times x plus 1 quantity squared equaling, I think this other side is going to equal 400, but let's double check that. 191 plus 25 times 9 minus 16, yes, 400. And it's no coincidence here that 25 times 16 is 400, because when we divide out everything by 400, here's what's going to happen. You're literally going to have y minus 3 quantity squared over 16 minus x plus 1 quantity squared over 25 equal to 1. So for this one, the center will be at negative 1, 3. Even though this y comes first, the fact that the center has to be from an xy standpoint has to work that way. So we're going to go up and down 4 units. and left and right by 5 units. 5. All right, so basically, yeah, you'd go up 4 and over 5. And since it's going to be on this axis, it'll look something like this. Oh, beautiful. Not so beautiful. All right, so what we need to do here is figure out the foci. So c squared is literally going to be 16 plus 25, which is 41. C is going to be the square root of 41, which is like 6 and change. And here's the thing. It is going to lie, let's see, 1, 2, 3, 4. No, it's going to be pretty far away from there. So what will happen here is the x-coordinate for the foci will remain constant. It's the y-coordinate that's going to change. You know, the center was at -1, 3. So the two foci are literally going to be located at -1, 3 plus root 41, and at -1, 3 minus root 41. And here's the thing, if you do an approximation here, 3 plus your square root of 41, it's going to be 9.4. 3 minus root 41 is going to be -3.4. Now the asymptotes are pretty simple here. It's going to be pre-transform or pre-shift. Y equals, let's see, you go up 4 and over 5. But after you shift, it's going to be y minus 3 equals plus or minus 4/5 times x plus 1. And just move the 3 over. Y will equal plus or minus 4/5 times x plus 1 plus 3. So, all right. So, what I want to talk about here is a parabola. And a parabola is going to be the set of all points in a plane that are equidistant from a fixed line called the directrix. And what's going to happen there, and it's also going to be the fixed point called the focus. So basically, it's going to be a similar distance here. And we're going to learn a couple of other terms that come with the territory here. So a parabola is going to have a standard form with the vertex at the origin. We haven't shifted yet, where y squared will equal 4px. That's a parabola pretty much on its side, like you see here, or x squared equals 4py. Now, from that, we're going to be able to figure out the values of the focus and the directrix. So, we're going to graph this parabola here and identify the focus and directrix. Now, the thing is, conventional wisdom in, if this were 171, you would just solve this for y, but we're going to identify it from a focus and directrix deal here. So basically, yeah, you have x squared equals 3y, and if you remember, x squared would equal 4py. So And if x squared equals 3y, basically what you're going to be able to do is figure out your p-value, so to speak. Our value of p. If 4p equals 3, p is going to equal 3/4. So, and since this is x squared equals 3y, we're going to be able to identify the directrix as the line y equals -3/4. So this is going to be the value of your directrix. Excuse me. And the point for the focus, it's going to be at 0p. So it's going to be at 0.3/4 here. And of course, it's going to have its vertex at the origin here. And we're also going to be able, so yeah, we're going to be able to draw this. But before we actually draw this, I want to introduce one more topic for this that's on the next page that ties directly into this. And yes, you can laugh. It's the latus rectum. Latus rectum of a parabola is a line segment that passes through the focus and is parallel to the directrix, and it'll have its endpoints on the parabola. So regardless of the form of the parabola, whether it's a y squared or an x squared, it's the length of your latus rectum is going to be the absolute value of 4p. So what that means is, the latus rectum, it's going to be the absolute value of 4p, which is the absolute value of 4 times 3/4. Which, whether the p-value is positive or negative, the purpose here is the latus rectum is always going to be a positive value here, and it's going to have a length of 3. Now, let's keep this in mind here. It goes through the focus. Now, that's our focus point here. It will be parallel to the directrix as we see right here. Now, this latus rectum, the length of it's going to be 3. Now, here is kind of the million-dollar question. What is half of 3 is what? 1.5. So you'll take this point here, and it'll go 1.5 units in both directions. And then we literally can draw the curve this way. And that is the only drawback to this pen pad, that it does not, But if you notice, this length of the latus rectum is going to be 3 units. If you go 1.5 units away, it's going to have a y value of 3/4. Now, again, conventional wisdom, you have x squared equal to 3y, y equaling x squared over 3. Now, if we go to the calculator real quick, so I'm going to pull up the calculator right quick, and I'm going to graph this, y equals, because it's a standard graph here at this point. X squared over 3. Now, if we go to 1.5, what happens is we do get 3/4, which happens to be the value of our focus. So yeah, this latus rectum ends up going through the focus. And that enables us to kind of help us draw our curve in any way, shape, or form. So yeah, that's a parabola from this point of view, so to speak. Yes? For the directrix? Okay, so do you understand how we got our value for P? So basically the focus is going to be at 0.3, and the directrix is going to be the line y equals the additive inverse of that, -3/4. So yeah, the directrix is a line here, and it's going to be parallel to your latus rectum. All right, any other questions on this? All right, so that it will, whether it's x squared or it's y squared, the latus rectum is going to be parallel to your directrix in either way, and it's going to go through the focus. You know, the focus meaning the point, not a forward focus.
Well, in cases of whole numbers or radicals, we would just have to take half of the radical.
Yeah, but we're not going to deal with radicals for this. Trust me on that. Yeah, the p-value is never going to be a radical.
It feels like we would start getting a lot more complicated.
It won't. Believe it or not, it won't. Now, what I want you to do here is I'm going to give you the focus and the directrix. And I want you to find the equation, and then you're going to graph it. And then from that, you'll also be able to find the latus rectum. Plot the focus, which is going to be at 3, 0, and you're going to have a directrix at x equals -3. So this is what I like to call a parabola on its side, so to speak. So the equation is going to be, is it going to be of the form x squared or y squared? It's going to be of the form y squared. So, do we have a value for P? You look right above, you'll see, yeah, your focus and directrix have the same value here, although the sign is switched. So our value for P is going to be, it's going to be 3. So, and if you remember, you know, y squared is 4px, or you've got y squared equal to 4 times 3 times x, or 12x. So the equation in question is going to be y squared equals 12x. You notice kind of the pattern here with both of the conics that we've done so far. I've always asked you one question where I've given you the focus. Now, I'd just like to throw that out there. But, by the way, what is the length of our latus rectum going to be? It's going to be 12. So it's going to go 6 in each direction. That's right. So basically, you'll go 6 units above. It's not the best looking drawing. You're right. I should. And it's going to be centered at the origin here, and it's going to look something like this. Not the best looking drawing here, but if y squared equals 12x, one thing you can do here is you could solve this for y, or you could take the square root of 12x, not 112x. Take the positive square root of 12x and the negative square root of 12x. And yeah, looks kind of like what we just graphed here. And for whichever equation you choose, like where x is 3, y is going to be 6. And if you chose x equals 3 here, y would be negative 6. So yeah, we can get that rather easily here. All right, any other questions before we move on from this? So what we're going to do now is we're going to kind of change things up a little bit. We're going to move the vertex away from the origin. And here's a good thing. The vertex is still going to be HK no matter what. You know, H being the x coordinate, K being the y coordinate of the vertex. And you literally have, if it's parabola on its side, I like to call it, you have y minus k. The k is still related to the y here, equals 4p times x minus h. And if you have x minus h quantity squared equal to 4p times y minus k. So yeah, what a lot of people would do if they saw something like this, especially in 171, they would say, oh, I'm going to solve that for y. No, don't do that. So what you're going to do is you're going to want to find the vertex. And when we transform the vertex, we're going to be able to transform the directrix and the focus with that. So your first order of business is simply going to be to figure out where is the vertex in all of this. It's going to be at 3, negative 2. So yeah, 3, negative 2. And since this is x squared, it's going to be a up-down style parabola as opposed to left-right. So what you can do here is we need to figure out the p-value, or the value for p. So 4p is simply going to equal what? What's that? All right, so basically you have x minus h quantity squared equal to 4p times this. So 4p is simply going to equal 2. So p is going to be 1/2. Now, you could literally follow these equations to figure out the value for the focus and the directrix here. But I kind of like to look at it this way. The original, or pre-shift, the coordinate for the focus is going to be at 0, 1/2, and the directrix will be the equation y equals what? It's just going to be, it's right in front of you here. We're not transforming it or shifting it. Remember, the focus and the directrix deal directly with the y value or the p value. So the y value for that directrix, positive or negative? Make it negative 1/2. So even though I'm going to draw these on here real quick, I'm actually going to be transforming them. And you'll see what I mean. because this is one thing I actually do like about OneNote. Now, so basically, because our vertex is 3, -2, what happens is, in fact, what I should have done was drawn the vertex at the origin to go with that. There we go, close enough. So basically, I'm going to take all of this and watch this. I'm going to move it 1, 2, 3 units to the right and 1 and 2 units down. Now, it might be my limited art skills or whatever, but thanks to moving all of that, we basically moved everything 2 units down. So, and 3 units to the right. So our focus is now going to be located at 3, but what about the y coordinate? -1.5. Yeah, because 1/2 minus 2. 1/2 minus 2 is -1.5. And the directrix is moved 2 units down. So -1/2 minus 2, that's going to be -2.5 or -5/2. Now, you could also, if you did k minus p, the k is -2 minus 1, minus p. So since p is 1/2, -2 minus 1/2 is going to be -2.5. Oh, let me rewrite that a bit. Yeah, -2.5. Now, yeah. So, but here's the thing. This has a y value of -2. The focus is 1/2 a unit above. The directrix is 1/2 a unit below. Now, how about the length of our latus rectum? It's going to be absolute value of 4 times 1/2, which is simply 2. Now, remember, the latus rectum goes through the focus. So 1/2 of 2, though, is 1. So you're going to go 1 unit in both directions, and it's simply going to look like this. So basically 2 units, 1/2 in each direction. So that's what we're going to get for that. All right, any other questions on this particular one? Now, I'm going to throw one at you kind of like this here. Instead of doing this, I'm actually going to go ahead and give you the equation directly. Our next example will actually entail completing the square. I just love completing the square. So we can think of this here. So our 4p is going to equal what? 3, so p will be 3/4. Now, the vertex of this parabola is going to wind up being located where? 3, 1. And that's going to be your vertex here. Now, I always like to basically think of it as, yeah, you're moving it to the right by 3 and up by 1. I always do it, this is kind of like my approach here. The original focus was at 0, 3/4, and the original directrix was y equals -3/4. But thanks to the magic of mathematics, we move that focus, which should have been here, and we move that, obviously, how many units to the right and how many units up? Three to the right and 1 up. So basically, you're going 3 to the right and up by 1. So basically, the new focus is going to be at 3, and 3/4 plus 1 is 1.75. And -3/4 plus 1 is what? +1/4. So if you notice, again, yeah, the directrix is right about here. Well, yeah, close enough. And the directrix is 0.75 units away from your vertex. It's also 0.75 units away from your focus. And how about the latus rectum? What is the length of your latus rectum going to be? It's going to be 3. Very good. So, and does the latus rectum go through the vertex or the focus? Focus. Focus on the latus rectum. Yeah. So anyway, it's 3 units. Half of 3 is 1.5. So I'm going to go roughly 1.5 units away. Half the distance to the goal. We draw it and we are done. All right, now, so if you notice here, yeah, if you actually did solve this for y, the x squared winds up being divided by 3, and this is a horizontal stretch compared, but we're not even going to touch any of that. But that's why this looks a little wider than usual. Now, I'm going to give you a quadratic equation in standard form. So you have -1/8 x squared minus x minus 5. Now, what we'll do here is we'll move this 5 over, and you're going to get y plus 5 equals -1/8 x squared minus x. And kind of for simplicity, let's flip-flop them. Equals y plus 5. So what you'll be able to do here is to complete the square for x. You'll want to factor out a -1/8, and I'll give you a couple of moments to do that. And keep in mind, you're going to be adding something to the other side as well. So I'll give you a few moments on that part. Oop, not that. All right, so if we factor out -1/8, that gives us x squared, and don't forget we have the y plus 5 here. Now, what's going to go in front of the x here? Plus what? All right, so negative 1/8 times what is negative 1x? What's going to go in here? It'll be x squared plus 8x. Very good. Now, here's the thing. We still have to complete the square for that. And what is going to complete the square inside of this? $16. Pretty sweet. Now, here's the thing. We didn't add 16 to both sides, though, because this 16 is technically multiplied by what here? Negative 1/8. So basically, it's plus negative 1/8 times 16. So what we've got now is negative 1/8 times x plus 4 quantity squared equal to y, let's see here, 5, negative 1/8 times 16 is negative 2. So this becomes a y plus what? Y plus 3. Now, there is one more step that we need to take here to get rid of this fraction. What can I multiply both sides of this by? Negative 8. So I'm going to kind of just move that over here. So I'm going to multiply both sides by negative 8. And what happens is those offset, and I have x plus 4 quantity squared equaling negative 8 times y plus 3. Now that you have this whole mess done, you can now figure out your p value, or value for p, and your all that other good stuff. So 4p is going to equal negative 8. So p is going to be a negative 2. Well, p is a negative value for the first time. How do you like that? So the original focus is going to be at 0, negative 2. And the original directrix, I'll just call them OF and OD, even though I don't know if I should, but y equals 2 here. Odie. I had a dog named Odie. All right, so, where's our vertex at now? Negative 4, negative 3. So what happens here, there, negative 4, negative 3. So we shift it to the left by 4 and down by 3. So the new focus is going to be located at negative 4, negative 5. Excellent. And our new directrix will be y equals. And this is why I like it when the value for p is an integer, because you see it so much better. Here's your vertex, directrix 2 units above, focus 2 units below. Boom. Mic drop. All right, and how's about the length of the lattice rectum? It's going to be 8 units. So remember, it's going through the focus, so you're going to go 4 units on each side. and it'll look something like this. Now this is an upside down parabola, and rightfully so, because if you notice, the equation is y equals negative 1/8. And that's how it's going to look. Not a bad deal. All right. I have in my hand the last parabola we're going to work on for today. Did this. So you have negative 1/6 y squared plus 2/3 y equal to x plus 5/3. Take out the negative 1/6. Oh, let's fix that. And this is obviously going to be a minus here. So basically, negative 1/6 times what is 2/3, or you can think of it as 2/3 divided by a sixth, or 2/3 times negative 6, which is negative 4. And you're going to add something to both sides on this. And yeah, it looks kind of scary here, but you're going to add 4 here, and minus 4 times 1/6. So you have negative 1/6 times y minus 2. Yeah, negative 1/6. Y minus 2 quantity squared equal to, well, let's see here. X plus 5/3. 5/3 minus 2/3 is 3/3, or x plus 1. See, all the fractions are gone now, except for that negative 1/6 in the front. Well, we subtracted instead. But what you can do is you can think of it as adding this and multiplying it that way, because that's a negative 1/6. I probably should have done it that way instead anyway. So,
That's how I did it when I produced to make it
you know what?
fit with all the other ways that we do it.
That's what I should have done. That's what I will do from now on. If I don't do it right, feel free to buzz me. Not really, I don't know. And let's multiply both sides by negative 6. And even though the p-value is going to be a fraction, it's not going to be too bad. I lost my 1. Well, I have to get it back. We multiply both sides by negative 6. And this time now we're at y minus 2 quantity squared equal to negative 6 times x plus 1. So 4p is negative 6, and p is going to be negative 3/2. So we're going to then move the focus and everything with that and see what happens. But we'll do that when we come back on Monday, because we're out of time. So far is we figured out the value of p for this. So here's the thing. So the original directrix the equation for the original directrix is going to be x equaling 3/2. And the original focus, and that's exam busters in case, that's, yeah. And it's going to be located at negative 3/2, 0. But we're going to transform this. Now, first thing we need to know is we need to know what our vertex is going to be. Well, our vertex is going to be located at negative 1, 2. So negative 1 and 2. And this is going to be a parabola on its side, so to speak. So you'll have that. And then what we'll do with that basically is, yeah, if you remember the original directrix, so it's going to be a parabola facing this way. In fact, what I should have done was kind of draw it over here a bit. So what happens is we literally shift the directrix 1 unit to the left. So 3/2 minus 1 is going to be x equaling 1/2. So yeah, x equals 1/2. And we shift that focus, we subtract 1 for the x, so the new focus is going to be at -5/2 and +2. So our new focus is going to be right here. Now, of course, if we actually took this as it was and we had the vertex there, what you see here is, yeah, here's your original directrix and your original focus, but we literally move it 1 unit to the left and 2 units to the right. And the next thing we need to do is length of the lattice rectum, which is going to be the absolute value of 4 times -3/2, which is going to be 6. Now remember, the lattice rectum is parallel to the directrix and it goes through the focus point. So the length of the lattice rectum is going to be 6. Half of that is 3. And that's what we get here. And it's going to look something like this. Probably would look better. But, one thing I'm going to do here real quick. Yeah. So let's see here. Entry. I can just literally do a relation. X equals, what was that again? -1/6 y squared plus 2/3 y. And what was it? -5/3. Was it plus or minus? It was -5/3. Come on. And sure enough, there it is. So if I want to analyze the graph in conics, for instance, yeah, lattice rectum, it's going to be 6 units. So in other words, I am hopefully just trying to get you to, hopefully selling you on this. All right, so with that in mind, I've got one more parabola for you to do. All right, so basically, let's move some things around here. So you have 1/8 x squared plus 3/4 x equaling y minus 25/8. Now, what's going to happen here is you're going to be able to factor a 1/8 out of this and complete the square. And the other side should get rid of any fractions here. I didn't mean to stop it there. So if we take out the 1/8, that's going to be x squared plus, let's see here, 3/4 divided by 1/8, or 3/4 times 8, that would be 6x plus something, and that's going to be y minus 25/8 plus 1/8 times whatever we put here. So in other words, what's going to complete the square for this? 9. Many moon come, that's a 9er. So you have 1/8 times x plus 3 quantity squared equaling y minus 25/8 plus 9/8. Well, negative 25 plus 9 is negative 16, or y minus 2. So now you literally have 1/8 times x plus 3 quantity squared equaling y minus 2. Well, what we want to do now is go ahead and multiply out both sides by 8. And you have x plus 3 quantity squared equaling 8 times y minus 2. So I'll give you, all right, so let's figure out our value of p. So 4p is going to equal 8, p is going to equal 2. So let's see here. So the original directrix and the original focus, well, since this is y equals, the focus is going to be located, let's see here. So if we look here, remember the original focus was, negative 3/2, 0. This is going to be at 0, 2, and y equals negative 2 for the original directrix. But we need to know what the vertex is. Well, that's easy enough. What's the vertex for this? Negative 3, 2. So basically, the original vertex starts at 0, 0, but our new vertex is at negative 3, 2. So we literally move everything 3 units to the left and 2 units up. So the new directrix will be y equals what? 0. And then the new focus will be located where? What's that? Negative 3, 4. Because here's the other way to remember this. So negative 3, 4. Here's your vertex. It's 2 units away from the directrix, and the vertex is 2 units away from the focus. And for the lattice rectum, it's going to be the absolute value of 4 times 2, which is 8. So we go 4 on each side, and it's going to look something like this. And if you notice, it's y equals 1/8 x. And since that value in front of the x squared, I meant to say 1/8 x squared, since the value in front of the x squared is less than 1, it becomes a horizontal stretch. So that's what that's going to look like for you. Now, one thing I'll do is I'm going to give you have a positive x squared but a negative in front of the y squared. So if one of these is positive and the other is negative, it looks like this is going to be a what? It's going to be a hyperbola. So let's factor out something from the x and the y. So you have 25 times x squared plus 8x plus blank. And we're going to factor a negative 9 out of this. And this is going to be y squared plus 4y, because negative times a positive has to be a negative, plus blank. And we're going to have negative 139 over here. But don't forget, we're going to add and technically subtract something from both sides. But once we figure that out, we're going to keep moving. All right, so to complete the square on x, we're going to have 16, and for y, we're going to have a 4 here. So you have negative 139 plus 25 times 16, whatever that is, and minus 9 times 4. But nonetheless, it's going to be 25 times x plus 4 quantity squared minus 9 times y plus 2 quantity squared equal to whatever this mess is. Not really a mess, but you have negative 139 plus 25 times 16 minus 9 times 4, or 36. And let's see, 225. Well, that's not a surprise, because here's the thing. We're going to divide everything in this equation by 225. And when we do that, 25 times 9 is 225. So we literally have x plus 4 quantity squared over 9 minus y plus 2 quantity squared over 25 equaling 1. So this is going to have a horizontal major axis. Let you figure out the rest of this. So let's see here. So we're going to have this centered at negative 4, negative 2. And, obviously A is going to be 3, B is going to be 5. So, and since this is a hyperbola, c squared is going to equal a squared plus b squared. So c squared will equal 34. C will equal plus or minus the square root of 34. So, and that's something just under 6 here. So we're going to be centered at negative 4, negative 2 here. So the horizontal, so we can kind of draw a box around this. We go 3 units away horizontally and 5 units up and down vertically. One day I will get this right. And what we can do with that here now is, let's see here. So we can kind of just draw our stencil, so to speak. And in fact, what I should do is kind of shave that off a little. Oh, what the? Come on, respond. Not getting much of a reading here. But the focus of this, let's see here. So, okay, we're not responding here. There we go. Yeah, sometimes it takes a minute to catch up here. Yeah, these computers, yeah, well, it's no matter what, but all right. So the focus, or the foci, where's the foci for this going to be located? Well, the y-coordinate is going to be negative 2, and it's literally going to be negative 4 plus root 34, negative 2, and negative 4 minus root 34, negative 2. So negative 4 plus root 34 is going to put us right about here, and going to put us right about here for the foci. And then we can draw the curve. Not the best looking drawing, but that's what we're going to get here. All right, so let's do another conic. I'll throw this one here, to say the least. All right, so let's factor some stuff out here. So you have 36 times x squared minus 10x plus blank, we know it's going to go here, plus 49 times y squared. 294 divided by 49, I should know what that is. I wrote the problem. Minus 6y, bless you, by the way, plus blank. And that's going to equal, 1764 minus 1341. Why I put this here, I don't know, but I did, and we're doing it. This will be 423, but we're going to be adding on both sides. Adding everything. So plus 36 times 25, and 9's going to go here, plus 49 times 9. So let's see what we got here. 423 plus 36 times 25 plus 49 times 9. And that's going to be 1764, which is what 36 times 49 is going to be. So you have 36 times x minus 5 quantity squared plus 49 times y minus 3 squared equals 1764. So we're going to divide out by, you guessed it, 1764. And we get x minus 5 quantity squared divided by 49 plus y minus 3 quantity squared divided by 36 equal to 1. So with all that in mind, we're going to be able to figure out the foci and other good things too. Now, if I were to ask a question like this, on a final exam, I would just say identify the conic and figure out the center. The center is going to be at what? 5,3. So 5,3, and the other downfall is basically your horizontal axis is your major axis here, and you're going to go 7 units away. So we're going to go off the charts for that. And for the vertical, you're going to go 6 units away. So it's almost going to be like a circle, not quite. But that's what we're going to get here. Now, if you remember, how do we figure out the foci for this one? Well, that's easy enough. First thing we got to do here is we've got to figure out, c squared. Now, if you remember, because this is an ellipse, c squared is going to be a squared minus b squared. So it's literally going to be 49 minus 36, or 13. C will equal plus or minus the square root of 13. Now, the foci will be located right on the horizontal axis here. Now, what I ask, so basically, the foci is going to be at 5 plus root 13, 3, and 5 minus root 13, 3. So 5 plus root 13, that's, square root of 13 is just under 4. So it's going to put us here and going to put us right around here too. All right, so Now what I asked, so we're going to start on parametric equations. We're not going to finish them today, but we should be able to actually finish them tomorrow. And once we finish that, we'll be able to ultimately start preparing for the final. Now, the final will be given over 2 days, and I'm going to tell you exactly what's going to be on it. So, and the questions are not going to go as deep as the regular tests have gone. By the way, I am still working on corrections. I forgot to take them home over the long weekend, but I am working on that. All right, so here's what we're going to do. So we're going to jump into parametric equations. Suppose that t is a number in an interval I. A plane curve is going to be the set of ordered pairs where x will be f of t and y will be g of t for a t in interval I. So what we'll do here basically, I'm going to give you a curve, and what you're literally going to do is you're literally going to figure out the x and the y values. Now, we're going to be able to ultimately also eliminate parameters, but we call it parametric because they're given in forms of x and y. So basically, what you need to do, well, first thing we can do here is I'll show you how to graph this on a calculator. Now, for mode, now we have done function and polar. We're not going to do sequence, but we're going to go now to parametric. So you can click on parametric. And from there, here's what we're going to do. If you notice, you have a x component and a y component. And when you click on this button, you notice, yeah, it's t squared. Oh, that should have been t squared plus 1. And the other one for y is going to be 2t. Now, if you go to the window, notice that I have the t between -3 and +3, and we're going to go incrementally of 1 in 1. So it's going to look kind of like this. And yes, it looks like a parabola on its side, but what we're going to do here basically is figure out the x and y values. 1. T step is 1. All right, so with that in mind, let's figure out some values here. So yeah, -3 squared plus 1, that's going to be 10, and 3 times -3 will be -9. So this will be at 10, -9. And if you notice, yeah, 10, -9, if I go to trace and type in 10, no, if I type in 3 for t, I'm sorry. Oh, wait. That's 2t. I don't know why I did 3t. Well, that's easily repairable. It'll be 10, -6. So you're going to figure out the rest of these values, and once you do that, you'll be in good shape. We'll plot the curve, and then I'll show you how we eliminate a parameter. Now that's on the docket for tomorrow. But what we're going to do now is we're going to go ahead and stop it here. And this. All right, so yeah, we have x equal to t squared plus 1, and y will equal 2t. And t will go between -3 and +3. So if we do, -2 squared plus 1, that's going to be 5. -1 squared plus 1, that's going to be 2. This will be a 1. This will be a 2, 5, and another 10. So 2 times -2, that's -4. So you'd have 5 with negative 4. This is negative 2, 0. And let's see here. This is going to be a 2, 4, and 6. All right, so we've got all of our points here. So what we can do with these points here is we can go ahead and plot them starting where t is going to be negative 3. And that's going to start us out at 10, negative 6, which is going to put us right here. Then you have 5, negative 4. 2, negative 2. 1, 0. You have 2, 2. 5, 4, and then 10, 6. So basically it starts here, off on the take here, so to speak. And it's going to go in this direction here. Now, all right, so so I've got to switch the mode to parametric. And let's see here. So this was t squared plus 1, and this was 2t. Now when we go to graph, we need to change our t values from negative 3 to positive 3. And if we do it as a step of 1, here's the thing. It does not look like as smooth of a curve as we would like it to be, because basically it does it every single unit. Now, if we go to the window and change the t step to say like 0.1, it's going to look something a little bit better, just like this. Exactly what we want. So there's that. Now, one thing that we're going to do is we're going to learn how to eliminate parameters. Now, the other thing that I want to mention is I do have the units take-home test ready to go. In my quick shuffle to leave my office this morning, I forgot to actually print them. I'll bring them tomorrow, but if you want an early copy, I'll have them outside of my office in 321 Dogwood today. So, what we can do here is we can literally eliminate a parameter in a set of parametric equations. So, we're going to find the rectangular version of this equation first. So what we can do here is actually very simple, not draw that, but we're going to type in 5 cosine of t minus 1 for x, and for y, you have 2 sine of t plus 2. Now, generally, t will be between 0 and 2 pi. And when you go to graph it, this looks like an ellipse. Well, it's going to be an ellipse. But one thing we're going to be able to do here is we're going to be able to eliminate the parameter very easily. So basically, you can solve x equal to 5 cosine of t minus 1 for cosine of t. And you'll do the same thing for y, except you'll solve that for sine. So basically, you have x plus 1 equal to 5 cosine of t, and then we divide both sides by 5, and literally get cosine of t equal to x plus 1 over 5. Now what I want you to do is to solve y equal to 2 sine of t plus 2 for sine of t. All right, so you have y minus 2 equal to 2 sine of t. Then we divide out by 2 here, and you literally have sine of t equal to y minus 2 over 2. Now, you have cosine of t and sine of t. And what you can do here is you can literally, if you remember this equation, sine squared t plus cosine squared t will equal 1. So you're literally going to replace sine of t with y minus 2 over 2. And square that, and cosine of t, x plus 1 over 5 squared equals 1. And because I am painfully OCD here, I need to put the x first, even though, well, but you have x plus 1 quantity squared over 25 plus y minus 2 quantity squared over 4 equals 1. And therefore, you have an ellipse. You've got yourself an ellipse. Now, it's going to be centered at negative 1, 2. And we're going to go 5 units away horizontally and 2 units away vertically. And this is what we get. A football. All right, not bad. So yeah, basically what we did here was we simply eliminated the parameter in this one. So you're going to do basically the same thing with the next one, except you're going to solve for tangent and secant. And if you remember one of your Pythagorean identities, sine squared plus cosine squared equals 1, you'll be able to get the tangent and secant one very easily. All right, so here's the thing. If of course, you know sine squared t plus cosine squared t is going to equal 1. And if we divided everything by cosine, what that's going to give us is tan squared t plus 1 equals secant squared t. Or basically, secant squared t minus tan squared t will equal 1. So this is going to be a hyperbola. So x equaling 2 tan t minus 2 for tan, you have x plus 2 equal to 2 tan of t, and then we divide by 2. Tan of t is x plus 2 over 2. So now you have y minus 2 equal to 4 secant of t. We divide out by the 4s. And you have secant of t equal to y minus 2 over 4. Now, it's going to be secant squared t minus tan squared t equaling 1. So that's what we're going to get for this. So basically, yes, secant squared t, you have y minus 2 over 4 quantity squared minus x plus 2 over 2 quantity squared equal to 1. Or literally y minus 2 quantity squared over 16 minus x plus 2 quantity squared over 4 equal to 1. So what we need to do here is, since the y is positive, it's going to be an up-down hyperbola. So what we can do here is, first off, we need to figure out where this is centered. And where's this going to be centered at? Negative 2 and 2. Boom. And what you'll do is, yeah, so for these ones, yeah, I would not make you find the focus and all that good stuff. We're going to go 4 units above and 2 units to the side. And it's going to look something just like this. You know, here's your little box. And if you draw your curve, that is not the best looking thing. That's close enough. See, that's a little better. And then it's going to look just like this. It's going to kind of ride the curve. All right, any questions? Oh, you know you can graph this on your calculator. It's actually pretty easy. Watch this. So you have 2 tan of t minus 2. Now, for secant of t, it's literally going to be 4 over cosine of t and plus 2 right after that. And it'll look something like that. Let's see. All right, not a bad deal if you ask me. All right, how about you try the next one? Oh, not that one.
Silver Ward glasses that he
Yeah.
used for his reenactments. Making those lenses was like probably one of the funnest things I've ever done.
Oh,
Just making glasses before.
I might have to look into that.
Like, just working on the frame, just like because he had like an actual antique frame
Wow.
that we were working on, and it was like just holding it was awesome. I actually had to cut those by hand because I couldn't use the machine.
Wow.
Because the frames are just so just different. The machine can't even have the frame in it.
Right, so if we remember the basic equation of secant squared t minus tan squared t equals 1. So this time you have x plus 2 quantity over 2 quantity squared minus y minus 1 over 3 quantity squared equals 1. You know, secant squared minus tangent equals 1. So you have x plus 2 quantity squared over 4 minus y minus 1 quantity squared over 9 equals 1. So this, again, is another hyperbola. So we're going to have it centered at negative 2, 1. And this time, the horizontal axis is going to, it's going to be horizontal major axis. So we're going to go 2 units away this way. And so yeah, we can draw a little boxy. Okay, why aren't we? There we go. See, that's the beautiful thing here. And then we draw our curve. Oh, that is beautiful. That is as good as it's going to get here. All right, now we'll have one more. We're going to be back to an ellipse. One day I'll get this right. So you have x minus 1 equal to 3 sine of t, and dividing out by 3, you have sine of t equal to x minus 1 over 3, and y minus 2 equals 5 cosine of t, dividing out by 5er, and we've got cosine of t equal to y minus 2 over 5. So literally by plugging in sine squared t plus cosine squared t equaling 1, it's very simple here. You have x minus 1 over 3 quantity squared plus y minus 2 over 5 quantity squared equal to 1, or pretty much x minus 1 squared over 9 plus y minus 2 quantity squared over 25 equals 1. And we plot this, so it's going to be centered at 1, 2. Buckle my shoe. And we're going to go 3 units horizontally and 5 units vertically. And it'll look something like this. And I think I went too far down. We can fix that. See? And that's what we got. All right. Now, believe it or not, we can replace parameters even for non-trig related equations. In other words, something like this. You can convert this to a parabola in conic form. So basically, since you already have x equals t, replace these t's will become x's. So you have y equal to negative 1/2 x squared minus 2x plus 2. So you get to complete the square and all that good stuff and plot that. All right, so yeah, you have negative 1/2 x squared minus 2x equal to y minus 2 here. You can take out a negative 1/2, and that would become x squared plus 4x plus something. And you have y minus 2. And we're going to have a 4 that completes the square, but that's a negative 1/2, so minus 1/2 times 4. So you literally have negative 1/2 times x plus 2 quantity squared equal to y minus 4. Because negative 1/2 times 4 is another negative 2. Negative 2 minus 2 is negative 4. But we'll multiply both sides by negative 2 here. And you have x plus 2 quantity squared equal to negative 2 times y minus 4. So you literally have 4p equal to negative 2. P will be negative 1/2. Now, I'm not going to give you one like this on your final or anything, because, yeah, the ones on your take-home test, basically you'll be given this and be told to figure out everything related to it. But, you know, the original focus is going to be located at 0, -1/2. And the original directrix will be y equals +1/2. But we transform that, we move it 2 units to the left and 4 units up. So the new focus is going to be located at -2, -7/2, and the directrix gets moved up by 4 units to y equals 1/2 plus 8/2, which is 9/2. Okay, basically for the original form of the focus, the p-value, the focus is going to be 0p. And since p is negative, that's why. Oh, because it's got to be the opposite. Yeah, it's going to be y equals -p for the directrix. See, this is why, again, I make this test a take-home. For this very reason. Well, plus, we just don't have the time. Actually, I'm kind of blessed this semester. We didn't really have much bugging, you know, getting in the way of things. Like what they would do, like, yeah, we'd get like surveys or something. Yeah. So the lattice rectum is going to be 4 units, so it's going to look basically like this. And that's what we're going to do, is solve x equals the square root of 6t for t and substitute. Now, you don't have to, you know, you can sub it in here, but when you do this, yeah, it'll be y equals something x squared. So if we solve this for t, you have x squared equals 6t by squaring that. So basically now you have y equals x squared over 5 minus 6 over 5 minus 4/5 x. So what we can do at that point is kind of just rearrange it, so to speak, and you'd have x squared over 5 minus 4/5 x equal to y plus 6/5. So what you'll be able to do is you'll be able to factor out a 1/5 on one side and kind of take it down from there. So if we go about this problem here, so if we take out a 1/5, that becomes x squared minus 4x plus, and to complete the square, half of -4 is going to be -2, and that squared is going to be 4. And you have y plus 6/5 plus 1/5 times 4, which is 4/5. So you have 1/5 times x minus 2 quantity squared equal to y plus 10/5, which is 2. And then we multiply out both sides by a 5 here. And we have x minus 2 quantity squared equal to 5 times y plus 2. So I'll let you figure out here is we'll figure out where it's centered in, or it's really more of a vertex at this point. So the vertex is actually going to be at 2, -2. 2, -2 kind of down here. And since it's going to be positive, it is going to be facing upward here. But what we can do here is, if you remember, the original focus. Now, oh, by the way, not 4, yeah, it is 4p. Yeah, 4p is going to be 5. P is going to equal 5/4. Now, I wouldn't give you one like this to solve. 5/4, that's kind of asking a little much here. But the original focus is going to be at 0 and 5/4. But since we moved to the to the right by 2 and down by 2, the new one literally becomes 2 and 5/4 minus 2, 2 and then negative 3/4. Yeah. And the original directrix was y equals negative 5/4. But since we moved that down by 2, it's now going to become y equals, negative 5 minus 8, negative 13/4, which is basically 3 1/4. And it'll look just like this. So the focus and the directrix are still equidistant from the vertex itself. And the lattice rectum is going to have a length of 5, which, and half of 5 is 2.5. And it's going to look basically just like this. Now, I can go ahead and just tell you, yeah, you're not going to have anything like this brutal on your final. All right, so with that said, though, this is, my finger went on the button a little too soon. Off with, what's the amplitude of this first one? Nope. It's just 4. Remember, the amplitude is the absolute value of what's in front. You might be thinking phase shift. Yeah, we'll get into that in a little while. And what about the amplitude for this second one? The amplitude is going to be 5, plain and simple. All right, so let you try these ones. Simple example here. So if sine of alpha is 12/37, cosine of beta is 7/25, and we're putting both of these into the first quadrant. So we can simply draw a triangle here. And here's alpha. Sine of alpha is 12/37. So we find the missing side here simply by taking 37 squared minus 12 squared, and that's 1225. Well, the square root of 1225 is simply 35. So basically, cosine of alpha is going to be 35/37. And if we do everything for beta, even though, yeah, it's not the best looking drawing here, cosine of beta is 7/25, adjacent over hypotenuse. So if we took 25 squared minus 7 squared, this is going to be 24. So basically, sine of beta is going to be 24/25. So cosine of alpha plus beta, what's that going to be? Well, by the way, again, this will be on your formula sheet, which, I'll show you the formula sheet that I'm going to give you on your final exam on both parts of it. For 172, tests, final. Oh, come on, open up for me. There we go. All right, so yeah, cosine alpha cosine beta minus sine alpha sine beta. And again, yeah, minus sine alpha sine beta. So let's see here. We have 35/37 times 7/25 minus sine of alpha, which is 12/37, and sine of beta, which is 24/25. So we know the denominator is going to be whatever 37 times 25 is for 925. So for the numerator, yeah, you have 35 times 7 minus 12 times 24, and that's going to be negative 43. And even though alpha and beta were both first quadrant angles, if you add two first quadrant angles together, their sum will be in the second quadrant, and that's why the cosine ends up being a negative. So for the sine of alpha plus beta, let's see what we get for that. So sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. So it's actually going to have the same denominator as before here. So you have 12/37 times 7/25 plus 35/37 and 24/25. So if you're keeping score here, this is going to end up being a positive angle. 12 times 7 plus 35 times 24, that's going to be 924 out of 925. Pretty simple. Now, cosine of beta over 2. So we go to one of our half angles here. And we know since beta is a first quadrant angle, half of that still has to be a first quadrant. So it's going to be plus or minus, and that really depends on what beta is. You would have plus or minus 1 plus cosine of beta over 2. But you're going to take the positive version of it. So, yeah, you have 1 plus cosine of beta, which is 7/25 over 2. And here's the thing. This one, so 1 is 25/25 plus 7/25, dividing that whole thing by 2. You have 32/25 entirely divided by 2, which happens to give us 16/25, which nicely gives us 4/5. And whenever you have a half angle on your final exam, there will be no radical for it. In other words, I'm going to make it as simple as possible here. So that's what you got for that. Cosecant. And remember, cofunction, the angle that forms the cofunction here is the complement. So how do we figure out the angle that we need? Subtract it from 90. So this is going to be the cosecant of 69 degrees. Now, tangent of pi over 5, the cofunction for that is going to be cotan. And if it's given in radians like this, I want you to give me the final answer in radians. So remember, pi over 2 is 90 degrees. All right, so basically this is 5 pi over 10 minus 2 pi over 10. So this is cotan of 3 pi over 10. That's all. This is simply a what? A circle. It's going to be centered at 11 and negative 13 and radius of 41. And yes, that's my newest inflatable. It's a 12-footer. First off, if you look at this, you know, this is a sum and difference here where it's sine cosine plus cosine sine. And so basically, you literally just add the arguments. So it's literally going to be the sine of 19 pi over 21 plus 3 pi over 7. Now you're probably thinking, oh my God, how the heck is this going to work? Well, first off, you got to convert that 3 pi over 7 to what? You're going to convert that over 21. So you have 19 pi over 21, and we multiply the top and bottom of this sucker by 3, 9 pi over 21, which is now the sine of 28 pi over 21. Well, that 28 over 21 simplifies if we divide the numerator and denominator by 7. 4 pi over 3. Sine of 4 pi over 3, which is going to be straight up on your unit circle. In other words, it's a unit circle angle. And what's that going to be? Negative root 3 over 2. Is figure out the magnitude of this. So we take negative 12 and square it, and 35 and square it, and this is going to end up being 37. So basically, the vector u is going to be negative 12 over 37 times I plus 35 over 37 times j. That's it. All right, we do have time for a quickie. One more quickie, and then we'll call it a day. Would I do this? You know, first off, yeah. See, at 327 degrees times pi over 180 degrees. So we have 327 out of 180 times pi. Well, here's the thing. If you remember this, if you add the digits of 327, they add to 12, which is divisible by 3. So 327 is divisible by 3. and we get 109 pi over 60. And nothing else can simplify there, so that's going to be it. So if it's a sine function, sine or a cosine, you basically take whatever is in front of the x and you would do 2 pi over 3 and simplify it if need be. But that's all the period's going to be for that one. Now, if it's a tangent function, you don't divide 2 pi by what's in front of that. You divide it by pi. Pi divided by 1/3, well, that means the period is going to be 3 pi. There's going to be no like graphing on this final or anything like that. It's not going to be like several parts to one question or anything like it is on the test. It's going to be a little more surface level, so to speak. So yeah, so you'll have that. All right, so basically this R value is going to be 8, and your theta is going to be pi over 3. So basically you would just do, for the rectangular, it would be 8 times cosine of pi over 3. Well, your formula sheet that you'll be given on the test will also have a unit circle here. So basically 8 times 1/2, which is 4. And then the y value would be 8 times the sine of pi over 3. Well, that's just 8 times root 3 over 2, or basically it's going to be 4 root 3. So the rectangular version of this is going to be 4 and 4 root 3. This is a sine cosine minus cosine sine here. And this is going to be basically the sine of 274 degrees minus 34 degrees, which is the sine of 240 degrees. And in looking at your unit circle, what are we going to get here? Negative root 3 over 2. All right, so I don't know why this thing is kind of stumbly today, but oh well. So what we want to do here now to find the cosine of, say, 7 pi over 12, we could probably split this off into 2 angles, or you could use a half angle identity or a double angle identity. So there's a couple of ways you could do this, but I think it might be, and I don't know why this thing is like kind of stumbling today. Let me see. I could split this up into, say, cosine of 3 pi over 12 plus 4 pi over 12. Now you're probably thinking, you might be thinking, oh, why would I do that though? Because pi over 12, but the thing is, yeah, pi over 12s are not on the unit circle, but 3 pi over 12 is in fact pi over 3, and 4 pi over 12, no, that's pi over 4. And 4 pi over 12 is pi over 3. So what we can do with that is very simple. Cosine of alpha plus beta, you can literally just do cosine of pi over 4 times cosine of pi over 3. And it'll be minus sine of pi over 4 sine of pi over 3. All right, so cosine of pi over 4 is root 2 over 2. Cosine of pi over 3 is 1/2. Sine of pi over 4 is again root 2 over 2. Sine of pi over 3 is root 3 over 2. So it's literally going to be root 2 minus root 6 over 4. Now, cosine of 7 pi over 12 is going to be a negative because 7 pi over 12 does put you into the second quadrant, and that's obviously going to be a very negative answer. So that's what you'll get for that one. All right, so with that in mind, let's try this one. The sheet's going to be 2 pages. All right, so Z1 is going to be 4 cis 150 degrees, and Z2 will be 2 cis 60 degrees. So that's what you'll have for that. So in order for us to figure out Z1 times Z2, basically you would just do 4 times 2 times cis 150 plus 60. And of course that's in degrees. So that's 8 cis 210 degrees. Now 210 degrees does put us into the third quadrant. So both of these are going to end up being negative here. So if you took 8 times cosine of 210 plus I times the sine of 210 degrees, let's see here. Cosine of 210 from our unit circle is negative root 3 over 2. And sine of 210 is negative 1/2. So basically what we get here is negative 4 root 3 minus 4i. So yeah, you'll have that and that. For Z1 over Z2, it's literally going to be 4 divided by 2 times cis of 150 minus 60 degrees, or 2 cis 90 degrees. And you can write it out or whatever, but it's actually going to be very simple to do here. 2 times cosine of 90 plus I sine of 90. Well, cosine of 90 is just what? 0. Plus, and sine of 90 is 1. So it's just going to be 2i. Now for this last one, I'm not going to be as strict. If you give me the angle as 450, I'm not going to penalize you. But basically, it's going to be 4 to the third times cis 3 times 150 degrees. So that's going to become 64 cis 450 degrees. Now, if I subtracted 360 from that, even though I said you could leave it like this, I'm not. Here's the thing. I want to get the rectangular form of this. 450 minus 360 is 90 degrees. So basically, all this is going to be is 64i. Or 0 plus 64i. All right. So I will throw in a lot of cosines on you here. What was the good example that I had? All right, so basically we can use the law of cosines in order to start finding our angles here. And what we can do here, we can start with, C here, or we could start with A. It really doesn't matter. But you have A squared equal to B squared plus C squared minus 2BC times cosine of A. And we subtract B squared and C squared. You have A squared minus B squared minus C squared, and then divided by negative 2BC, that will equal cosine of A. And if we go ahead and plug that in, and we decide to figure out what is going to be the cosine of, okay, well, I guess, that is weird. Why it's doing that. Yeah, we'll close that up. All right, so what we'll do then is we'll just kind of do this here. Let's see here, 17 squared minus 21 squared minus 26 squared over negative 2 times 21 times 26. And that's going to be 69 over 91. So the measure of angle A is going to be the inverse cosine of 69 over 91. Times 180 over pi, and we're going to get 40.7 degrees. Yeah, I cannot figure out why for the life of me that it's going to do that. Okay, so cosine of B is going to be B squared minus A squared minus C squared divided by negative 2AC. So let's see here, 21 squared minus 17 squared minus 26 squared, negative 2 times 17 times 26. And this is 131 out of 221. And we take the inverse cosine of that, times 180 and over pi. That'll be 53.7 degrees. And basically, take those away from 180, and we get measure of angle C equal to, oh, come on, 85.6 degrees. All right, so that's what, so you'll kind of have that little luxury here. So if we let u equal to 3x plus pi over 4, you have negative 2 sine of u equal to 1, and sine of u equaling negative 1/2. So FYI, you will have a unit circle at your disposal for the final exam. And that's going to be basically so yeah, where is the sine going to be negative 1/2 at? What are the two values of u for which that's going to happen? What's that? 7 pi over 6, and what else? Yep. Now, keep this in mind here. The period of this function becomes 2 pi over 3. So basically, we literally have 3x plus pi over 4 equal to 7 pi over 6, we have 3x plus pi over 4 equal to 11 pi over 6. So what we need to do, I think the easiest way to go about something like this is to multiply both sides of each equation by something to get rid of those fractions, and that's going to be a 12. So what we're going to have is 36x plus 12 pi over 4, that's 3 pi, equal to 14 pi. 36x will equal 11 pi. X will be 11 pi over 36. Now, keep this in mind. 2 pi over 3 is going to end up being 24 pi over 36. So we do the same thing for this one. 36x plus 3 pi equals, let's see, 11. This will be 22 pi. 36x will equal 19 pi. X will simply be 19 pi over 36. Now, those are two of the solutions. Now, for each of these, we can keep adding increments of 24 pi over 36 until we're outside of the region. And I would tell you on the final, if I were giving this to you, there would be 6 solutions between 0 and 2 pi. You know, I'm going to tell you how many solutions there'll be. So if we had 24 pi over 36, this would be 35 pi over 36. And if I added another 24, that's going to be, let's see here, that should be 59 pi over 36. Now, if I added another 24 pi over 36, that takes us beyond. So we don't need that. Now, for this one, if I added 24 to 19, we would have 43 pi over 36, and then 67 pi over 36. So the trig equation that you will get on your final exam will be either a sine or a cosine. I'm not going to throw a tangent or secant or cosecant at you. None of that kind of stuff, so you'll kind of just luck out there. All right, so I'm going to give you a moment to catch up. And the other one, for the second one, that'll end up going to the left here. So basically, you just simply set the argument equal to 0. 3x will equal pi over 2. And we can multiply by 1/3. But x is going to be pi over 6 to the right. So yeah, you'll just have to determine the phase shift and the direction. Or if the argument like this, or if this value becomes a positive, yeah, we know that that's going to go to the right.
We can also just do C over B, right?
Yeah. Effectively, yeah. So for this one, 4x plus pi over 3 equaling 0. 4x will be negative pi over 3. X will be negative pi over 12. And this one is going to the left. All right, so we're going to end up completing the square twice on this. And 288 divided by 36, that will be 8. And that should be minus 8y equals 851. Well, 25 is going to complete the square on this one. And minus 36 times 16. So this is 25 times x plus 5 quantity squared minus 36 times y minus 4 quantity squared equal to, let's see, 851 plus that minus, that'll be 900. Well, here's the thing, 25 times 36 is going to be 900. So if we divide out everything by 900, we get x plus 5 quantity squared over 36 minus y minus 4 quantity squared over 25 equal to 1. Now, what kind of a conic is this? What? Hyperbola. Yep. This one's going to be a hyperbola with a center of -5, +4. Boom. We let u equal to 4x minus 2 pi over 3. Yeah, 4 cosine of u equal to 2. Cosine of u is going to be 1/2. Now, so basically, you'll have it at pi over 3, and what's the other one? 5 pi over 3. Now, as I said, I will tell you the number of solutions that you'll be looking for in this case. It'll be 8 in this case here, so let's keep this in mind here. The period is 2 pi over 4, or simply pi over 2. So you have 4x minus 2 pi over 3 equal to pi over 3. You have 4x minus 2 pi over 3 equal to 5 pi over 3. Now, conventional wisdom would say multiply everything out by 3 here, but the nice thing is everything's, you could just add 2 pi over 3 and we get 4x equal to pi. X will equal pi over 4. And let's see here. This is 4x equal to 7 pi over 3. X will be 7 pi over 12. Now, this would be 3 pi over 12, FYI. So what we can do is we can call this 6 pi over 12. And you can give them to me in simplified or unsimplified forms. But we would get 9 pi over 12, and then 15 pi over 12, and then lastly, 21 pi over 12. And then for this one, 13 pi over 12, 19 pi over 12, and then lastly, 25 pi over 12 goes beyond it, but 7 pi over 12, you could actually subtract 6 and get simply pi over 12. So yeah, as I said, I'm going to be looking for all the solutions, and you can give them in degrees if you wanted to. So you kind of have that look. Now, if you gave this to me in polar cis form, I would accept that too. So basically, I mean, yeah, you could do it as -4 plus 4i root 3, but here's the thing. Doing the math to find the r value and the angle, it all works the same way. But in rectangular form, this is going to put us into the second quadrant, and it's going to put us somewhere right about here. You have -4, then you have 4 root 3, and it's obviously going to be a second quadrant angle. So basically, r is going to be the square root of -4 squared plus 4 root 3 quantity squared, which this is going to end up as the square root of 64, or 8. Now, what we can do to find the angle is very simple. We can call this theta prime, and we could subtract it from 180 to find the actual theta that we're going to need here. So I could use a tangent. I could use any sort of ratio here. I could just do, the sine of theta prime equal to 4 root 3 over 8, which is root 3 over 2. So that means theta prime is going to be the inverse sine of that. And of course, I will give you a unit circle to use. And this is going to be pi over 3 . So basically, you could take, or 60 degrees. So basically, 180 minus that, it's going to be 8 and 120 degrees, or 8 cis 120 degrees. What's it called? A bearing or anything. I'm not going to throw one like that at you. So let's see here. Yes, so we're going to go 430 miles due west. Yeah, I know, I'm a little creative here. And 375 due north. So basically, this is just a Pythagorean theorem question. All right. So let's figure this out. And it'll be 570.55 miles. All right, not too bad. All right, so basically all you do is multiply by pi over 180, and you get 245 pi over 180. Now let's get that in simplest form. Well, we can divide both of those by 5. And that's going to be 49 pi over 36 radians.